So these are very important because you should know what will be next. For our case of cobalt here, so the next sub-energy level is what? 4s. And the 4s is going to accommodate what? 2 electrons. So total it is 20. The next level is what? 3d orbital. Right? 3d orbital. So the next here is what? 3d orbital. Okay? So the next after 4s, if you now want to check the sub-energy level. So it means the next here is 3d orbital. So you have to learn what will be next after the 4s. And then how many electrons remains? We have 18 plus 2, it is 20. 27 minus 20 is equal to 7. So all the 7 electrons will be filled in what? In d orbital. But remember that the poles, the Hans rule should be also followed, that in case of d sub-energy level or sublevel and d f sublevel, we say that these are stable orbitals if they are either half-filled or full-filled. So you should fill first the 5 electrons into the 5 orbitals of d orbital, and then you start pairing from the beginnings of the sublevel to the end of the sublevel. So for this case now, it means that each orbital will have 1 electrons, and then the first and second orbital will have to pair the electrons, because we'll fill 5 electrons into each orbital of 5 orbitals, and then we'll pair electrons in the 2 orbitals to complete the number of electrons, which is equal to 7. So then that's electronic configurations. You can draw now, maybe by using the box method. It's fine. So you are done, and you enjoy now the beauty of advanced electronic configuration. Chemistry is not complicated. The advanced chemistry is not complicated, but it depends on who taught you and how you are being taught. Then I want to give you another example. Okay? This just you can call it example 1 for this case. And here also I have example 2 or example 3, whatever the case, just to call it. So let us example 2, because I don't remember exactly. Using the box methods and arrows, draw electron configuration of the following element. So this is a little bit concept, because I will show you where the concept. Using the box method and what? Box method and the and arrows. Arrows to what? To draw the electronic configuration. Electronic configuration, okay? Electronic configuration of the following element. The following elements. The following elements, right? The first one will be given the name of elements. So if you be given the name of elements, the first step, you should know the atomic the number of electrons contained. Chromium, and they'll be given the symbol, which is Cr, capital RC. And then they've been given what? Copper. Say copper. Okay, copper. And this one is the symbol for copper. I believe that you enjoy the beauty of chemistry and advanced chemistry. Again, I would like to inform you that in case you have your eldest brother, your young brother, who is pursuing diploma in engineering, I'm also teaching engineering mathematics for diploma students and engineering physics for diploma students. And the channel, my official YouTube channel also is called the Online Diploma Poly Institute of Tanzania, Olenjolai, in square bracket Olenjolai. So you can search in the YouTube search engine. Good. Okay. So you say that you'll be given so many elements, 2 elements, chromium, sedoti, and copper. So I would like to leave one also at your homework, and you have to be careful when you be writing this electron configuration because a little bit tricky. Okay? So I'm trying to plan. Okay, so do it for copper, and you have to take care. So let me leave you there. So write the electron configuration for copper. So this is the homework. I will do for chromium. So it says solution. In this question, we are given the number 40 of an element, but we don't know the number of electrons. So the first step, you can use the modern periodic table in your mind if you remember, or if you have, you can check. First step, identify what? Identify the number of what? The number of electrons. Number of electrons. The number of electrons contained in what? Chromium element. By using what? Periodic table. So you find that, for example, that by using the modern periodic table, you say that chromium contains how many electrons? So you go to your periodic table, and then your modern periodic table, you look for chromium, which symbol is Cr, and you'll find that this is chromium. Its atomic number is 24, so the total number of electrons is 24. So chromium contains 24 electrons. Within 24 electrons, there is in electrons, and or we call them score electrons, and valence electrons. Okay, so if that's the case, we have to use the boxing method. So for box method, in some of the books, they include also the noble gases. In some of the books, they write an open or long box method. So I think the best one is writing the long box method for you, who is a beginner, so to understand the concept. So the second step, we say that using the box method and arrows to draw so we say that draw the electronic configuration, right? Electronic configuration, okay? Draw the electronic configuration by what? Of what? Of chromium now, which contains 24 electrons, by using what? By using boxing method. So let us go step to step. We are writing the electron configurations of 40 of chromium, right? Of chromium. So we are writing these electron configurations of chromium. We say that this will be equal to it. Always you start with s orbital, one s orbital. Then the next one, we got the 2s orbital. Then the third one, we got the 2p orbital. Then the next one, we got the 3s orbital. Then the next one, we go to 3p orbital. Isn't it? Yes. And then now we start to draw our orbitals. This is s orbital, because it contains only maximum 2 electrons. So this is 2. So this is what we have here. And then here we are. So here we have 2 electrons. Hence, this is the point where we are. So then this contains 6 electrons. This contains 2 from the noble gas. So you have to have field first, the orbital, then we pair. That's the principle of writing electron configuration. Again, we have the s sublevel. Also, we have paired electrons. So here we have 2. Total, how many are they? 12. And then we have 3p orbital. 3p sub-energy level. How many orbitals does it contain? 3. 1, 2. So 3. So this is 1, 2, 3. How many electrons can accommodate? 6. So we have again 6 electrons. So total 18. So this we can place in right argon. Again, the next sub-energy level, according to the Paul's principle, will be according to the alpha principle, 4s. And this 4s containing what? 2 electrons, can accommodate 2 electrons. So total will be 20. And chromium has how many electrons? 24. So we still have 4 electrons. So then we draw it his box and using arrows. So these accommodate. So don't fill these electrons first. Don't fill these electrons first. Then we have the next sublevel, which is 3D orbital. Right? 3D orbital. Good news is it contains 3D sub-energy level. It contains 5 orbitals. 1, 2, 3, 4. So after having this, after filling these in electrons, because the inner shells here are 1, 2, 3. And then this is the first, this is the valence shell, including with the 3D. Okay. So the concept we say here that here we fill the 18 electrons in the inner shell. So 24 minus 18 remain with 6 electrons. So obviously we might think that we fill here 2 electrons and then the 4 remaining electrons we fill here, but will be disobey the half and the, which we call the full and half full rule. The full and half full rule state that the D and F sub-energy levels are in stable state if they are either half filled or full. Okay, so when I say that the principal quantum number here is equal to n is equal to 2 and subsequent quantum number is equal L is equal to 2, and then the magnetic quantum number for this case it is 0, and the spin quantum number we just write it in the next column in case that you don't see them clearly. So this is the way that you write. We say that the corresponding principal quantum number n is equal to 2, and then the subsidiary quantum number n is equal to 0, and the spin, the magnetic quantum number m is equal to 0, and the spin quantum number for the first electrons. Remember that I told you that the spin quantum number, if the spin quantum number is clockwise, is anticlockwise, then this corresponding to positive half. If it is downwards, means that anticlockwise, then corresponding is what? Is negative half. So the first electrons is down, is in clockwise direction. So it means that the spin quantum number will be negative a half. Chemistry is beautiful, and the question was good because it was testing real that whether you understood the concept of quantum number relating to the electronic configuration, because there we use the electronic configuration to identify the quantum number of electron in the certain energy level. Good. So we go for Roman 2. Roman 2 will be given the name of 40 of an atom, which is oxygen. The total number of electrons of oxygen is already, or in our mind, it contains 8 electrons. So then when you write, so it means we go straight for the first state. Okay, first state. And the first state we say that draw the electronic configuration. Draw the electronic configuration. Draw the electronic configuration of 40 of electron configuration of what? Of oxygen. Right? Good. So the electron configuration by using boxy method, because it's the one that will show the last electrons in the oxygen. So oxygen should be in uppercase. Say that this is oxygen, right? In uppercase. So then this is equal to what? Is equal to 1s. And then this is 2s. And then this is 2p. And then we say that here we have 2 electrons total, 4. the total number of electrons in the oxygen is 8. 8 minus 4, it is 4. So it means that here the p orbital will have 4 electrons. Okay, so we say that we are going to draw the orbitals, the box, okay, the boxes. Here we have spine, clockwise and anti-clockwise spines of electrons. And then here we have this spine. And then again here we have voting, we have again 3 orbitals in p orbital. So the principle, half filled first, the electrons, Paul says what he called according to the Hans law, half filled the electrons first. It means that until no pairing is allowed in the sub-energy level until every orbital is singly filled. Okay, so here we have 3 electrons, we still have 1 extra electrons, we have to fill it here. So this is the way we count. First electron, second electron, third electron, fourth electron. You see? Fifth electron, 6 electrons, 7th electrons, 8 electrons. Let me repeat. First electron, second electron, third electron, fourth electron. Look again. In p orbital, we fill electrons according to the sequence. Okay? According to the sequence. And it's the sequence. Okay, this is the sequence, this one, and this one. So we have what? 1 electron, 1 electron, 1 electron. So this is the 5th electron, 6th electron, 7th electrons. Let me explain. First electron, second electron, third electron, fourth electron, 5th electron, 6 electrons, 7th electrons. Good. 7th electron, so we still have 1 electrons. This is the 8th and last 20 electrons. So because this is the 8th and last electrons, so this is the last electrons, not this. Last electron in what? In oxygen. So because that the last electrons in oxygen, then what do we say? We say that because at the last electrons we find where? Remember that this is px, this is py, this is pz. So you find it in p orbital. So then we go for the second step. Second step, we say that identify what the corresponding quantum numbers, the corresponding quantum numbers, corresponding quantum numbers, we mean that principal quantum number, yes, the subsidiary quantum number, magnetic quantum number, and the spine quantum numbers. Okay, to the what? To the lasting or 8 electrons, lasting electrons, last electron of what? Of oxygen. So from this sequence now, the last electron is here. It's corresponding the coefficient of that orbital, which is p orbital. It means that we say the corresponding n is equal to what? To this is the principal quantum number, and then when n is equal to 2, we have possibility. It means that we have 2 subsidiary quantum number. L is equal to 2 minus 2, which is 0, and L is equal to 2 minus 1, which is 1. So if that's the case now, we say that fine. Yeah, so that's the case. So we have to check which sub-energy level did we find the last electrons. The last electrons we found in P sub-energy level. Because we found in P sub-energy level, then what do you say that? Because we found in P sub-energy level, it means that we are going to use the principle, the subsidiary quantum number, L, is equal to 1. Because when L is equal to 1, and then we say it is magnetic quantum number, which is M. This one, because L is equal to 1, is equal to -1, comma 0, comma +1. So this illustrating that it's P sub energy level, Px, Py, Pz. And then we go. This is Px, Py, Pz. We check the last T. We go now to the spine quantum number, which is M subscript of S. So the spine quantum number here, we come into the Px. Is the last electron the first electron or last? The second. The second electron is what? Is in clockwise direction. So because it's clockwise direction, it takes what? Negative half, negative value of half, or positive value of half, negative value of half. So this one is what? Negative half. Right? Negative half. So then that's the answer of the second Roman. Try this, said, and let me know in the comment section whether you are successful on solving it or not. So, this is the good time to say the ends of the lecture 17 of valence electrons and the core electrons, so valence shells and the core shells. Much more about it, it's digging into the concepts of electronic configuration. This is the end of the lecture. First of all, I declare publicly and I thank God who have prepared me to know these materials and prepare and collect them, and again that He helped me to teach you. I believe that you have understood what I taught you, and you will keep on understanding and revising them. And I would like to insist you that to revise, or to, it means to learn through this video several times as well as you can until the concepts click in your mind, more than even it has been clicking to me. I remind you that I fail to cram, and I will never teach you to cram, right? So I will teach you how to understand and how stuff works, and I will use the simple way of teaching and simple. I take complex problems and then I break them into the simple and simplest and useful concept. So I believe that you enjoy. Remember that to subscribe by using your valid email, and also remember that to share these contents to your colleagues, means to your friends, to other students who are pursuing the advanced in chemistry right now and even in the future. Young brothers tell them, because materials will be there. And then another thing, use the comment sections to ask more questions, read the descriptions of the video to get more information. And also, in case that you find that this program, or you feel from your heart, because I say that this remember that Olenjolai is a gift given to the United Republic of Tanzania in academics or in education. Okay, thank God for choosing me and seeing that I'm faithful and I can do it. So in case you want to offer your free willing or thanksgiving for this program, or for the more lectures on chemistry, on advanced chemistry, advanced physics, or A level, to be in air by using the internet, means that it will spread the entire world, and then send you a seed offering or your sensitive offering through this number, +255 759 74 5331, and the confirmation name is Olenjolai. In case you want to use other method of bank transaction, then read the descriptions below. Show more. You'll find much information about how you can participate in this program wirelessly. So thank you again very much for your time. Thank you for learning with me. Thank you for giving me an opportunity in your mind to teach you about advanced chemistry. May God bless you. I used to pray for you earnestly that to be successful in academics for the rest of your life and even your future and even your generations. And also I ask you to pray for me, because this is a very hard work. But before God, Almighty God, the God of Abraham, the God of Isaac, and the God of Israel, nothing is impossible. Everything is possible. He made those things which seem like complex into simple. So join me in the next lecture, where we are going to finish, or we are going to end. Possibly we have 1 to 2 lectures to finish the concepts of atomic structure, and then I'll be teaching you the concept of chemical bonding. So stay tuned, enjoy the contents, and then let us meet in the next lecture. I love you so much. May God bless you.